9.1 Inequalities and Domain. Let's go ahead and solve this inequality, and we'll go ahead and write the solution in set builder notation. We'll go ahead and graph it on a number line and write it in interval notation. So in order for us to solve this inequality, we want to isolate the t. In order to isolate the t, we have to start undoing all the operations. So we see first thing we need to do is this whole expression is being divided by -3, so we'll need to multiply both sides by -3. Now remember, this is the big difference with solving equations and solving inequalities. Anytime in an inequality, if you multiply or divide both sides by a negative number, your sign flips. So in this case, since I multiplied both sides by a negative number, my sign will flip. So now I have 2t minus 9. So now instead of greater than or equal to, I will have less than or equal to -21. Now we need to undo this minus 9 by adding 9 to both sides. So 2t minus 9 plus 9 is less than or equal to -21 plus 9. So we see that the -9 plus 9 equals 0, so we're left with 2t is less than or equal to -12. Now we'll go ahead and divide both sides by 2. That leaves us with t is less than or equal to -6. Okay, so the first thing let's do is go ahead and graph this on a number line. So I always put 0 for reference, so let's say 0 is here somewhere. Here's -6. I want every number that is less than or equal to -6. So that would imply I want everything to the left. And notice we wanted or equal to, so I also want -6. And remember, we always put brackets or parentheses facing the shaded region. So in this case, we'll put brackets opening up this way. Okay, now let's go ahead and do interval notation. So interval notation really helps if you have the graph. So you ask yourself, what's the starting point of my shading, or how far left can we go, how far right? So we see that this continues to -infinity. With infinity and -infinity, we always have parentheses. So parentheses, -infinity, comma, goes up to -6, brackets. And set builder notation, remember you always have your staple pieces, open curly parentheses, the variable in question, which in this case is t, that vertical bar which represents such that, and then your inequality statement. So the set of all t values such that t is less than or equal to -6. Okay, let's do another example. Let's try this one. We want to find the domain of this function. So if you remember, I have it in my notes, my lecture notes for section 9.1, and hopefully you will be going over the book as well. Anytime you're looking for domain, what you want to ask yourself is, basically, we want the set of all values that makes this function defined. So it's easier to ask yourself, what makes it undefined? So let's just remind ourselves the undefined list. What makes a function undefined? So the first thing is a 0 as a denominator. We never want a 0 as a denominator. And number 2, what makes a function undefined? A negative radicand for a square root. Okay, so we ask ourselves, do we have anything to worry about here? Do I have a denominator to worry about here? No, I do not. Do I have a square root sign? Yes, I do. Now, I do have a square root, so what do I not want? I do not want the radicand. The radicand is the entire expression on the inside as a whole to be a negative, okay? So let's just quickly look at a number line. We're going to break this number line into 3 parts. Right, we have the negatives, we have 0, and we have positive. If it cannot be a negative, we'll cancel out the negative, then what can this entire radicand be? It can be either 0 or a positive number. So let's set that up as an inequality. 2x plus 7 can either equal 0 or a positive number. A positive number means that it's greater than, so it can either either be greater than or equal to 0. Now we simply just need to solve this inequality. So I can go ahead and subtract 7 both sides. 2x is greater than or equal to negative 7. We'll go ahead and divide 2 both sides. So we have x is greater than or equal to negative 7 over 2. So any value for x that is greater than or equal to negative 7 over 2 will make this function defined. Let's go ahead and write this out in all three ways. So let's go ahead and graph. Here's 0 somewhere. Here's negative 7 over 2. I want every value greater than, which will be to the right, or equal to, so brackets faced towards the shaded region. I can go ahead and write my interval notation from here. Our starting point, the furthest left my shading goes is negative 7 over 2 with a bracket, comma, to infinity parentheses. And set builder will be open curly parentheses. Our variable in question is x, such that, and our inequality statement. Close those parentheses. Okay, and one last example. Let's do an application. So this application says Tony can be paid in one of two ways. Plan A, she can have a salary of $400 per month plus a commission of 8% of gross sales. Or Plan B, she can have a salary of $610 per month plus a commission of 5% of gross sales. For what amount of gross sales should Tony select Plan A? So remember, the first thing you want to ask yourself is, what are we looking for? That's where we look for the word find or the question mark. So this is what we are looking for. For what amount of gross sales should she select Plan A? Well, if you have a choice of being paid in two ways, you always want to choose the way that you'll be paid more. Everyone wants to be paid more, right? Well, now each one of these plans will give you more pay dependent on the number of gross sales that Tony makes. So let's first come up with an expression for Plan A and Plan B, an algebraic expression, so that we can go ahead and set this inequality up. So Plan A says that she'll have a salary of $400 per month. So that's just a standard salary she will get. So that's just $400 that she will have, plus 8% of gross sales. So remember, anytime we have percentages, we have to change that into a decimal of gross sales. So we don't know what the gross sales are, so we can call that X. Let's put that here. The number of gross sales that she makes will be X. So then 8% of that, the of implies multiplication. So this will be 0.08 times X. Now B. B offers a salary of $610 plus 5% of gross sales. Remember, gross sales represents X, and now we want 5% of that. So that will be 0.05X. Now we want to know, we want to solve for X. For what amount of gross sales should Tony select Plan A? So if she's going to select Plan A, that means we want Plan A to offer her more money than Plan B. So A should be greater than B. So let's go ahead and substitute now. A was 400 plus 0.08x is greater than 610 plus 0.05x. Now we can go ahead and eliminate the decimal right away, or we can actually start simplifying a little bit more. Why don't we go ahead and move the 400 over to this side, and I think we can actually just work with the decimal for now. So we'll go ahead and subtract 400 both sides. So that gives us 400 minus 400 plus 0.08x is greater than 610 minus 400 plus 0.05x. So that gives us 0.08x is greater than 210 plus 0.05x. Now why don't we go ahead and subtract 0.05x both sides. So if we subtract 0.05x from 0.08x, you can see 0.08 minus 0.05 gives us 0.03. So we have 0.03x is greater than 210. We can actually go ahead and get rid of the decimal here to make things a little bit simpler. Remember, to get rid of the decimal, we want to multiply by a power of 10 so that this becomes a whole number. So we need a number that has 2 zeros, right? That'll be 100. So I'll go ahead and multiply the left side by 100 and maintain the balance by multiplying the right side by 100. Now I have 3x is greater than 210 times 100 will be 210 with 2 more zeros, 21,000. Now we'll go ahead and divide 3 both sides. And that gives us x is greater than 7,000. Now what was the question asking us again? For what amount of gross sales should Tony select plan A? So as long as Tony knows that she can make more than $7,000 in gross sales, she should select plan A. So for gross sales greater than $7,000, Tony should select plan A.